Hey everyone, glad you're here because what you're about to hear isn't just surprising. It shakes the foundation of everything we think we know about objects drifting through our solar system. And if you've never heard of the 10th anomaly surrounding the mysterious visitor known as 3I Atlas, buckle up. The first few details alone are enough to make even seasoned astronomers stop and rethink the rules written into textbooks. So imagine this: a distant object gliding through space, expected to behave like any ordinary comet, shedding dust, glowing faintly, minding its own business. But when researchers aimed the Nordic optical telescope at it, something immediately felt off. The brightness didn't spread out the way normal comet light does. Instead, it stretched into an unexpected, razor-thin elongation angled almost perfectly toward the Sunday. Not away from it, not sideways. Directly into the solar direction with a precision that didn't match natural cometary physics. And this wasn't a tiny flicker. The imaged region spanned nearly 500,000 kilometers across. Even stranger, the filters used during observation blocked most gas emissions, meaning the dramatic structures seen in wider photos weren't just gas clouds. Something else was shaping that light. Then the deeper analysis began. Long-range jets, massive streams stretching up to 3 million kilometers were reported by other observations. But here's where things start to twist. Based on the velocity those jets should move at, they must have been active for months. Months of sustained output from an object that, by all calculations, didn't have the size or energy intake to power that kind of activity. It's like finding a flashlight the size of your thumb, somehow lighting up an entire stadium. Scientists ran the numbers again and again, and the math kept pointing back to the same unsettling conclusion. The energy required simply didn't match the dimensions 3I Atlas appeared to have. By the time the data settled, researchers were staring at something that shouldn't exist, a natural object performing at a level that defied the very physics used to define natural objects. And this was only the beginning. Tell me in the comments what part of this anomaly surprises you the most. I want to hear your take. The deeper you look into the story of 3I Atlas, the stranger it gets because the 10th anomaly wasn't some isolated oddity. It was the final piece stacked on top of 9 others, each one rare enough on its own, but together they form a pattern that has scientists whispering about possibilities they normally avoid. The first anomaly hit researchers like a jolt. 3I Atlas wasn't just moving in a retrograde orbit, it was gliding almost perfectly along the ecliptic plane, aligned within a few degrees. That combination is like tossing a coin into the air and having it land balanced on its edge. Then reports surfaced of something even harder to ignore. A jet pointing directly toward the Sunday. Natural comets never behave that way. Their tails are pushed away by solar wind, no exceptions. Yet this one appeared to break the rule cleanly, almost deliberately, creating a feature that left astronomers wondering if the forces at play were more complex than simple gas release. But the oddities didn't stop there. Rumors swirled about its size and speed, refusing to match the energy conservation laws comets are known to obey. The larger the object, the slower it usually travels, but 3I Atlas displayed the opposite, forcing analysts to double-check their calculations. Then came the orbital coincidences. Precise flybys of Mars, Venus, and Jupiter that aligned with uncanny timing, while the object conveniently slipped out of Earth's view near perihelion. Reports claimed the odds of all that happening by chance were staggeringly low. Add to that an unusual metallic composition, nickel and iron proportions with an almost industrial balance, and an extreme lack of water that clashed with what defines a comet in the first place. Its reflected light displayed a polarization never before recorded. Its path aligned suspiciously close to the direction of the old "wow" signal. And near the sun, it glowed with a blue intensity that no known comet material could replicate. Each detail on its own could be dismissed, but the full list was starting to feel like a cosmic riddle waiting for someone brave enough to confront it. What truly pushes this topic into controversial territory is the debate exploding inside the scientific community. On one side, you have researchers demanding caution, warning that rare natural events can look misleading when you don't have the full picture. On the other, you have voices like Dr. Avi Loeb insisting that ignoring data just because it's uncomfortable is the opposite of real science. He doesn't claim 3I Atlas is artificial. Instead, He argues that when an object displays behavior outside every known category, you don't shove it back into the old categories. You widen the framework. He points out that extraordinary discoveries often start as anomalies dismissed by experts who couldn't see past the theories of their time. Critics argue he's being too speculative, but he counters by sticking to the data itself, the statistics, the probabilities, the inconsistencies, and asking why it's controversial to say, we need to look deeper. Some discussions have floated the idea of non-natural mechanisms, like directed exhaust jets that could mimic thruster-like behavior, but even those claims are framed strictly as hypothetical models meant to explore what the observations could mean. Nothing definitive, nothing declared as fact, only possibilities laid out so the community can test them. And that's where the tension lies. For every scientist calling for restraint, there's another pointing out that breakthroughs often come from refusing to look away when the evidence refuses to fit the expected pattern. The real question isn't what 3I Atlas is. It's whether researchers are willing to examine every angle without flinching, even if the truth ends up challenging everything we currently believe about objects drifting between the stars. The real weight of this story settles in when you reach the final question, not what 3I Atlas is, but how we choose to handle something that refuses to behave like anything we've ever studied. Because once an object racks up anomaly after anomaly, once its energy output defies the math, once its trajectory, composition, brightness, and timing all fall outside every familiar pattern, the conversation stops being about the object itself and starts being about us. How do we respond when the universe hands us something that doesn't fit inside the rules we've written? Do we force it back into the old boxes? Or do we accept that maybe the boxes were too small to begin with? What stands out in all of this is the call for true scientific honesty, the kind that doesn't panic when faced with the unknown. Dr. Loeb keeps repeating a simple point. If the data challenges the model, you don't ignore the data, you update the model. And that idea, as straightforward as it sounds, has sparked more debate than the anomalies themselves. Some researchers want to slow down, gather more information, and avoid jumping to conclusions. Others believe the data already demands bolder thinking, not because the object must be artificial, but because the physics we're observing don't align with what a natural comet should be capable of. Both sides agree on one thing, though. Whatever 3I Atlas turns out to be, it deserves scrutiny without bias, without fear, and without dismissing possibilities simply because they make us uncomfortable. And that's the core of this moment. This isn't just about one interstellar visitor. It's about how science handles the unexpected, whether we approach it with curiosity or with defensiveness. The correct next step is simple. More observations from independent teams, more careful measurements, and more willingness to consider all explanations that fit the evidence. Not the explanations that feel safest, not the ones that protect old assumptions. The ones that match what's actually happening out there in the dark. Whether 3I Atlas ends up being an incredibly rare natural phenomenon or something entirely different, it's already forcing a shift in how future anomalies will be studied. And that might be the most important discovery of all, not the object itself, but the new standard it sets for confronting the unknown. Drop your thoughts in the comments. What do you think the future investigations will reveal?